Okay, get ready. I'm not really exactly sure what this video is going to be like. I just wanted to talk about electricity and what's the big deal? Why study it? Why is it important? So I made a little list here and let's go through it. What is electricity? Uh, Electricity itself, when you hear that word, electricity, you think of light bulbs being lit or computers being turned on. And I'm with you, but I want to go a step more basic. I want to talk about the electric force. Okay, so electric force is something that charged objects feel. So electric force is something that protons and electrons are involved in. So if you're a proton, you're positive. If you're an electron, you're negative. And these two things feel electric forces. If you've got a couple of protons nearby each other, they are going to repel. And if you've got a couple of electrons by each other, they are going to go shooting away from each other. They're going to repel. And if you have two of them that are opposites by each other, a proton and an electron, then they feel an electric force that attracts. Why do they attract each other? That's a great question. I do not know the answer to that. What is it that the proton has that the electron wants? I really have no idea why they attract each other. I don't know if anybody has that answer. But when they're like charges, they repel, and when they're opposite charges, they attract. Okay, something that you probably already knew. So, I guess that kind of addresses what is electricity. It's a force, electric force. Where is electricity? That's an easy question. Electricity is everywhere. It is everywhere. What does that mean, everywhere? Well, think about yourself. What are you made of? Well, as a human, you are mostly water, and you've got carbon compounds. There's sugars inside of you and proteins and all that good stuff. But let's just stick with water for now. In a water molecule, what have you got? You've got an oxygen atom. You got a couple of hydrogen atoms hooked onto it. And what's inside of those? Well, inside of each hydrogen atom is a nucleus that is positive, and the same thing for oxygen. And then going around the outside and all over the place, actually, there are these electrons zipping all over the place. And so why is it that a hydrogen atom would want to get together with an oxygen atom anyway? Well, that's because there are these attractive forces. Inside, this proton right here, this positive, feels an attraction for the electrons and the oxygen. And likewise, this proton feels attraction for the hydrogen's electrons. So these things are attracted toward each other, and that's what holds this thing together. So basically, electricity is kind of like the glue that holds all of us together. If there was no electric force, then you wouldn't have people. You wouldn't have planets. Well, maybe you would. Gravity would still bring things together, but they wouldn't be electrically bonded. So is it important? The answer there is, whoa, yeah, really important. Okay, so stepping sideways a little bit, let's talk about other stuff that you're thinking of with electricity. Batteries. What's going on inside of a battery? Inside of a battery, what you have is this. You've got different materials, and there's chemistry going on, and the chemistry that happens produces positive charges, and it produces negative charges. So then when you hook up a wire to a battery, when you hook up a wire to the battery, then you can use that battery to make things like light bulbs work. How about that for a drawing? That's actually not too bad, huh? So a light bulb works because it lights up, because what's happening is these little negative electrons, these little blue guys, are whizzing through the wire, and as they get forced through this filament, the filament gets hot and it gives off the light, and then the electrons wind their way back up into the battery. So a battery is an example of using chemical energy to get light. And then you think of things like circuits. You can have a battery. The symbol for a battery is like this, and you can run electricity through a light bulb, and This drawing and this drawing are essentially the same. This is just what we call a schematic. And we'll study those. Or maybe you have already, who knows. And then finally, where does our power come from? Where does our electric power come from? Our electric power comes from moving electrons in wires. So somewhere far away, most likely, you've got this factory, and what they're doing in this factory is they've got this big pile of coal, and they take this coal and they burn it, and then they use that to boil some water, and then when that water boils, oh, this is going to be a horrendous drawing, but that's what you're used to. So you take that water, you boil it, you turn it into steam, and that steam spins this fan around, and that's called a turbine, and we send that back over to get reheated again. And when this turbine spins around, it spins a shaft that is hooked to something called a generator. So inside that generator, what's happening is there are magnets and coils of wire. And when you spin a magnet near a coil of wire, or you spin a coil of wire near a magnet, what you wind up producing is electricity. So we take that electricity, we use a transformer to boost the voltage up, and then what do? We send that electricity through all these towers, and then finally out to our homes, where we get to turn on lights and watch TV and stuff. So that's where our electric power comes from. It's a big energy conversion thing going on. We've got chemical energy, we turn that into kinetic energy, mechanical, I suppose, and then we use magnetic and electric fields. We get the electrons, and we send the electricity to your house. And yes, if you send out a pulse of electricity one way, a pulse comes back the other way. But that is just the big idea, I guess, about electricity.